So last time we started looking at a system of linear equations, okay? Now remember, with a system of linear equations, I don't think I said this last time, the kind of, okay, oh wait, what the, okay. But basically with the system of linear equations we're dealing with, there's only 3 possibilities regarding the number of solutions. There's either there's either no solution, there's either only one solution, or there's infinitely many solutions. So again, there's either no solution, exactly one solution, or infinitely many solutions. Those are the only 3 possibilities. If there's no solutions, we say the system is inconsistent. And if the solution set is empty, and the solution set is empty. Now, if there's at least one solution, though, we say it's consistent. If there's at least one solution, we say it's consistent. Now, if there are infinitely many solutions, though, then we say the equations are dependent. Okay, so again, this is a consistent system. But the equations are said to be dependent if there are infinitely many solutions. And if there's only one solution, though, there's only one, that solution is unique, we say the equations are independent. I think in the other class I might have said linearly dependent or linearly independent, but that's all right. Okay, now how do you know when this happens? Well, when you're solving a system, we'll see there's actually different ways of solving such a system of equations. One of them is graphically. The other 2 do not involve graphs. But if when you're solving them, you get a false statement like this, 0 equals a non-zero constant, like 0 equals 1, 0 equals 2, something that's false no matter what the variables are, equal to, I mean. Then there are no solutions. But if you get a true statement with no variables, like 0 equals 0, 1 equals 1, 2 equals 2, then there are infinitely many. Then there are infinitely many solutions in that case. All right. So that's good. Okay, now let's keep going. So let's consider now one way to solve a system, which is actually using the method of substitution. So this is actually going to demonstrate it. Then I'll show you what the method is. So using this first equation, right? From the first equation here, okay, what we have is 2x minus y equals 5. Well, from the first equation, let's get y in terms of x. We can do things to the equations that does not change the solution set. Just like we've done earlier in the course. We have 2x minus y equals 5, right? So if you subtract 2x from both sides, we have minus y equals 5 minus 2x, right? That's what we get here. Minus y equals 5 minus 2x, okay? Again, we can solve for y in terms of x. Then from here, we don't want negative y, we want y, so we can divide everything by -1, and we get y equals -5 minus minus becomes plus 2x. So again, we had 2x minus y equals 5, right? We subtract 2x from both sides. We get negative y is 5 minus 2x. And again, we get y. We just get rid of the negative, essentially. We just divide everything by -1. Or you can multiply everything by -1. We get y equals -5 plus 2x. So we have y in terms of x. Y equals 2x minus 5. Okay, so that's what we have here. Okay, that's great. So from the first equation, we got y in terms of x. Okay, so what? Well, if that's what y has to be in terms of x, right? Then in the second equation, if we were to substitute, we would get this. X plus 2y is x plus 2 times 2x minus 5. Now that's the second equation, so this sum has to be 5. Okay, so again, we know what y is in terms of x, right? Well, let's put that into the second equation and see what happens. That's what we're doing. Notice that we get x plus 2 times 2x minus 5 equals 5. We get an equation only in x. Right? Essentially, the y is gone. We have an equation in only x, which we know how to solve. Namely, we get x plus 2 times 2x minus 5 equals 5. And so from here, we can distribute. We get 2 times 2x minus 2 times 5. So we get x plus 4x minus 10 equals 5. Right? And now again, after we distribute, so we can combine like terms to get 5x minus 10 equals 5. But again, we want to get x all alone. So we add 10 to both sides, okay? We get 5x equals 15, right? Because we added 10 to both sides, and then we divide by 5, we get x is 3. So x has to be 3. But remember, a solution is an ordered pair. So we need to know what y is. Can we do that? Well, yeah, because we know what y is in terms of x. I mean, that's down here. Replacing x by 3, we get 2 times 3 minus 5, which is 1. 6 minus 5, which is 1. So we have x is 3, y is 1. We get our solution set. The ordered pair 3, 1. So we have a solution here. Okay. So that demonstrates the method of substitution. Before I show you the actual method, well, actually, are there any questions on this? That's what I meant to say. Okay. So here is the actual substitution method. It basically is just an outline of what you have to do to actually, use the method to solve the equation. So this is what you do when you use the substitution method. Namely, you use one of the equations to get one variable in terms of the other. So one variable in terms of the other. That's what you do. That's like what we did, right? In this example, we got y in terms of x. You're going to substitute that expression into the other equation. That's what we did, right? Once we got y in terms of x here, in the second, what we did next was we took that y and put it in for the second equation. You want to use the other equation, so you put it into the second equation. What will happen is you'll end up with an equation in only one variable. In only one variable. That's what we do. And once you solve that equation in one variable, right, that's what we did. We solved it. We got an equation in only x, right? We solved that equation. We got what x is. We substitute back into what we got in one, that expression, to get the other variable. right? That's what we did. Once we knew what x was, we plugged back into the expression for y in terms of x. And then, of course, it's good to check by substituting. So again, that's just the outline of the method. Okay, we did one example. Let's do another one. So here, this one's kind of different, as you'll see. From the first equation, right, we have 2x minus 5 equals y. And then just like, the first example, you can get y in terms of x. Okay, that's what we can do. Now, put it into the second equation, right, just like we did in substitution. Once you get one variable in terms of the other, so we got y in terms of x, excuse me, we put it into the second equation, so we get 4x minus 2y becomes 4x minus 2 times 2x minus 5 equals 15. So that's what we get here. Of course, we distribute the negative. Now we have to figure out what this equation is. We have one equation and only one variable, x, right? So now what we have to do is figure out what x is. So we have 4x minus distribute the 2 minus 4x plus 10 equals 15. Right? Again, what am I doing? I'm distributing the minus 2. So that's how we get minus 4x. Minus 2 times minus 5 is plus 10. Doing so, we get 10 equals 15. Over here, the 4x's cancel. Well, this is not true, right? No matter what x and y are, 10 equals 15. That's impossible. What does that tell us? No solution.